Hi, welcome to week 2 of EPS88. Testing out a virtual background. This is Berkeley campus and then the Bay. It's working sort of okay. Okay, so in this video we're going to be practicing reading in data files that are in text format and then writing them as well. And actually, I don't need this. So the reading that goes along with this video is chapter 2.1. And so, say you get a brand new data file, either somebody sends it to you or you download it from the internet. The first thing you'll want to do is open that file in kind of the text editor of your choice. There's probably one that came automatically with your computer, or you can download a new one. I like to use Atom personally, but you can use whatever you are familiar with. So I'll drag the file that we're going to take a look at into Atom. And so I'm going to just start familiarizing myself with this data set. I can see that there are 3 columns of data that are, I can tell by this first row here, which I'm going to call it, this is the header. And this is telling me that the columns are longitude, latitude, and age in millions of years. I know just from having some context about this data that that's age of the seafloor in millions of years. So you'll also bring some outside information to the data as well. And then also from this, I'm learning that the symbol that is separating my different columns is a comma. And then once I get into the data, I just have what we call a float data type, which is numbers that have decimal values. Okay. But this is a fairly kind of basic data file. They can and will be more complicated. So this is another example. So this is a data set that I downloaded from the USGS. It's an earthquake catalog of earthquakes since the year 2000. So here I have some more header rows that are telling me information about the search that I did. And then also telling me that the columns of data here are the date time of the earthquake, the latitude, longitude, depth, location, its magnitude, and then some other information about kind of how the data was collected and what it means. Again, the symbol that's separating my different columns is a comma. And then in this example, I've got a mixture of different data types. So the first column, this is a string variable, but I also have float and integers. So I'll need to keep that in mind as I'm parsing in this data file. All right, let's go to a notebook and get practicing. Okay, so we're going to use both pandas and NumPy packages for this example. So I'll load those in. So I'll do import NumPy as NP. So that's importing the NumPy package and just giving it the nickname NP just for brevity. I'll do the same for pandas. Okay, so the first program that we're going to use, call, is going to be the NumPy load text program. And so then to get the documentation for that, I'm going to do NumPy load text and then a question mark and run this, and this will give me the documentation. And so from this, I'll learn what I need to pass to this program in order to read in my data. So I'm going to need to tell it what the file name is. That's fname. I'll tell it what I'll tell it the number of rows to skip. So that's telling it how many of the header rows there were. And I'll also tell it it's what we call a delimiter. It's the symbol that separates the different columns. And then, yeah, that information is also down here. So it's delimiter, it's the symbol used to separate values, skip rows, yeah, it's the number of headers. And so I'm going to load from my data file, and I want to pass it into a variable that I can then use. So I'm going to call it age data array. And then I'm going to use NumPy load text. I need parentheses, and then I'll tell it the the file name, which was age xyz.csv. I need to tell it how many header rows to skip. It was just one. And then what my symbol that are separating the columns is. And then I'll just print this out to check that it is what I want. Okay, yep. So now I have a NumPy array with 3 columns that are longitude, latitude, and age. But say I wanted to use those different columns separately as their own variables. I can parse this from 3 different columns into just single arrays. So I'll call the first row longitude. So I'll do that by doing from my age data array, I use square brackets to do the indexing. I want to take all of the rows, so use colon, and then I want this first column here, which is the 0 index, and then I'll just print it out so check that I pulled what I want. Okay, and so now this is a NumPy array that is just that first column of latitudes. Okay, so that's using NumPy load text and doing some parsing and indexing. Now let's take a look at pandas. We're going to look at read CSV since we have a CSV file. There's also other options you could use. Pandas read table, which is fairly similar, but since we have a CSV file, we use this one. Okay, so again, we'll look at the documentation to know what things we need to pass it. We'll need the file name still. The default for this particular program is comma separated since it's looking at CSVs, which is comma separated values. But it's a good habit just to still set what the delimiter is. You can do that with either sep or delimiter, and then we'll tell it how many headers to skip. Okay, and again, we're going to pass this to a variable. I'll call this one age data frame since it's going to be a pandas data frame object. Okay, so I will call pandas read CSV. I need to tell it the name of the file. I'll tell it that my separator was commas, and then we'll do a couple of different examples of the header because there's a few different options. Okay, so I guess what the default would just be with 0, and we'll run this and then print out what we get and take a look at it. Okay, so sort of the automatic thing it does if you tell it that there are 0 header rows, it assumes, and in this case correctly, that there's just one row and it's telling you the name of the columns, their longitude, latitude, and age. Which for this example was a good assumption. If we had done that other earthquake catalog example, it would have had some trouble because there were more than just the one header information rows. But there are other examples where you would want to set the header as something, or for example, if these column names had spaces or symbols that we didn't want, or if they were just like unuseful XYZ type labels. So we can tell it that there is one header row, so it'll skip that and not read it in, and then we can tell it explicitly what we want those columns to be named with names, and then I'll do lowercase just to show you that it makes them different. So I'll do long and age. Okay, and I'll run this again. Okay, and so now I've got columns that are named long, lat, and age. So I skipped the one row and told it what I want the columns to be named. Okay, so then why would you want to use pandas instead of NumPy? So pandas data frames have a lot of built-in methods codes that are really, really nice. We'll take a look at a couple of those. So I can do age data frame dot head, and that's going to print out just the first 5 rows. I could do, let me copy this, I'm going to do it a lot. Describe is a nice one. If I run this, this gives me the number of rows of each of these columns, what their mean, standard deviation, minimum, maximum values are. Some quick diagnostic information. And then each of these, within a data frame, each of the different columns is its own kind of data frame object. So for example, I could take a look at just the age column. So this is that column of seafloor ages, but then it also has kind of additional data frame information like the index values and its name and what type of information it is, that it's a float, and that's stuff that the kind of NumPy array of the same information didn't have. And so there's examples that we'll look at where that'll be really useful. To do similar indexing that we did their data frame, we can take I need to do data frame dot look for location. I want to take let's take just the first 10 rows, but all of the columns. So here we go. So if I run that, then now I have just the first 10 rows. So the indexing for data frames is slightly different, but still also additionally very powerful. I'm gonna name this something else. So now I'll have a new data frame called X. Ooh, I'll print it out. And then just to show you, kind of for example, if instead of taking the first 10, if I'd gone from 10 to 20, for example, this is keeping track. Like now, in this new data frame object that I just made, X, these still have kind of index values, but they're keeping kind of the original index values from my original data frame. So this has rows that go from 10 to 20 instead of going from 0 to 10, which sometimes is really useful, sometimes is annoying. Mostly it's just something to keep in mind. Okay, and then the final thing I'm going to show you is how to save. For a data frames object, it's really simple. So I'm just going to call my new data frame object, which I called X. I'm going to do toCSV, which is going to save that information to a CSV file. I'm going to name it seafloor age new.csv. So I'll run this. And then on my desktop, I have a new CSV file that I just made. If I take a look at it, it is that new data frame object that I just made. Okay, that is it. Thanks for watching, and I will see you in class.